Forgot to do that. Okay, so I'm going to subtract 12x from both sides. And that's going to give me negative 3y is greater than or equal to, whoops, that's a 12x. Negative 12x plus 9. So move the 12x to the other side. We need to divide. The number in front of the y is negative 3. So we're going to divide everything by negative 3. And remembering that when we divide an inequality by a negative, we need to flip the sign. So those 3's, negative 3's cross out, and I get a y, but my sign is going to turn into a less than or equal to. I'm going to flip the sign. Now, if you forget to do that, negative divided by negative is a positive. If you forget to flip the sign, that is a really good reason why you should do a checkpoint. So at the end, when you got your shading, check a point in your shaded region to make sure you did it correctly. Because if you forgot to flip your sign, your shading's not going to be right. Okay, so I now have my new revised form of my inequality. Y-intercept is negative 3, slope is 4. I see an equal sign right here, so I know I'm going to graph this with a solid graph. And I see that y is less than, so I'm going to be shading below. So let's do it. Negative 3, 1, 2, 3. Slope up 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Yeah. So there's the points where my line's going to go. I'm going to graph it as a solid line. Solid means that the points on the line are part of the solution. So the solution for this problem is going to be the shading and also the line itself. So all the points in the shaded region and all the points on the line are solutions. So below. Now this line, it's not vertical, but it's very close to vertical. And sometimes people have trouble seeing where below is when your line gets really steep like this. But if you don't know where below is, pick a point. Below means go down. There's my region right here. It's this region. Okay. So below literally means pick a point and shade down. Shade the region that is down. So there's my shaded region. Pretty yellow. You can shade it whatever color you want. You have a pencil, just lightly shade it, and that's all good. Okay, so there is my shaded region. I need to check that I did this correctly. So I want to pick a point in the shaded region. 0, 0 is not in the shaded region. So probably not a good idea to choose 0, 0. If you do want to choose 0, 0, you would be verifying that it's false because it's not shaded. So it's actually easier to just be consistent and always choose a point in the shaded region to confirm. So let's pick a point in the shaded region. Someone give me a point that's in the yellow. Any point you want that's in the yellow. There's a lot of them. Lots and lots and lots of points there. Okay, well, I'll choose one. I'll choose that one. And that happens to be 1, 2, 3, 4, 5, 6, 0. Not for any particular reason. I just chose 6, 0. Okay. Now, checking your point. Always go back to the original. Because if you forgot to flip the sign, this one's going to be wrong. Go back to the original. I know the original one is right because that's the one that I was given. Any other point in this problem, I might have made a mistake. So always go back to the original to check. So I'm going to do 12 times the x minus 3 times the y. The y is 0, so that's minus 0. Needs to be greater than or equal to 9, and that is true. 12 times 6 is 72. Subtracting 0 is definitely greater than or equal to 9, so this checks. Okay, so just check a point in the shaded region. Make sure that it is true. So that's how we do inequalities, linear inequalities, because they're all lines. That's all we're going to be doing is linear inequalities when you have two variables, an x and a y. So like I said, our notes today are doing this with, oops, I just realized I put the notes in for period 1, but I did not put them in for period 2. So give me a second to insert the notes into my notebook. And then we will take notes on systems of inequalities. So a system just means graphing more than one or solving more than one equation or one inequality. So doing a system of inequality is graphing more than one, which for us will mean two on the same graph. And you can do more than two. I mean, you could do 3 or 4 inequalities at the same time, but we're only going to be doing 2. Okay. So there it is. So this is our last notes for the chapter. So this is pages 11 and 12 in the notes. So we'll fill these in, you guys submit them today, and then this is the end of notes. Like I said, we will do a review assignment tomorrow on Delta Math. Got a fuzzy thing on my page there. So we'll do a review assignment tomorrow on Delta Math. And that works out well because I realized that, you know, with the holiday coming up, some people like in group A might not be able to Zoom in tomorrow. Of course, I do have to mark you absent because of the check-in, but if you are unable to Zoom in, all you'll be missing is that we're going to be doing a review assignment on Delta Math, so you can still access that review assignment, but you won't miss any instruction tomorrow outside of us just going over a warm-up and then me just helping people that have questions. So that's what we're doing tomorrow. And then again, after Thanksgiving, we'll have 3 review days, and then we will do our ESA. So solving systems of linear inequalities by graphing. Systems is a fancy word for more than one. That's what a system is. Whenever we say a system in math, it's just a way of saying more than one. So solving more than one linear inequality by graphing. And we're going to be doing 2. We're not going to do more than 2, even though we could, but we're just going to do 2. So first off, when we graph an equation, right, y equals mx plus b. So if we graph a linear equation, y equals mx plus b, the line, the reason we graph it is because the line represents every solution to that linear equation. We can't solve y equals mx plus b because there's 2 variables. So what we do is we plot all the points on a graph that are solutions, connect them, and they form a line. So that's why we call it a linear equation. So every point on the line is a solution. When we graph an inequality, whoops, except inequality starts with an I. An inequality, the solution is represented by an entire region on the graph. It's not just the line. The line is important because it's a boundary. It divides the graph into the 2 regions. One of them is the solution, one of them is not. But our solution is represented by the entire region. And we represent this region by shading it. So that is our conventional method for indicating where the solutions lie on a graph. We shade them. Okay, so that's what an equation is versus an inequality. Okay, and then from yesterday, remember we graphed a solid line if the line is included in the solution with a less than or equal to or greater than or equal to. So the equal to part is what makes us a solid line. We graph a dashed line or a dotted line if the line is not included. Notice if there's no equal in the symbol, no little line there, you're going to keep your line dashed or dotted. If y is greater than, so if you have this, y is greater than, and all the other stuff on the other side, you're going to shade above. So when y is greater than, you shade above. Otherwise, that would mean if y is less than, you shade below. Okay? Now, the solution region is where the solutions lie. So when we are doing a system, the solution region is where the shaded region is overlapping. So the solution region, and we should have said here, whoops, for a system means that you're graphing more than one, is where the shaded region overlaps. So here's an example. Here is a system of inequalities. There's two of them. How do we graph a system? We graph the first one. Y-intercept is 5, slope is 2. Line is dotted. Shading is below. And there is the solution right there. So that's our first inequality, y-intercept of 3, up 2 over 1, dotted line, and shading is below. Okay. Our second inequality right here, y-intercept -1, slope -1/2, line is solid, and shading is above. So we add that to our graph. Here's the line. Y-intercept of -1 right there. And the slope is down 1 over 2, down 1 over 2, down 1 over 2. The line is solid. And the teal shading here is above. Now what we're looking for is we just shaded all of this in yellow. We shaded all of that in the teal aqua color. The answer to the system is where does the shading overlap? And this is where they overlap. So it's hard to see it on the screen, but this is actually a little different shade of green than that because it overlapped and combined with the yellow. But this right here is the solution region. That means that any point in this solution region is going to be true for both inequalities. So the way that you check your shading is you pick a point in the overlap. For example, there's 0, 0. 0, 0 is in my overlap. I'm going to check 0, 0, or whatever point you want. I'm going to check it in both of these. So my first inequality, the y, which is 0, so right here I'll check it. 0 is supposed to be less than 2 times 0 plus 5. Well, let's see. 2 times 0 plus 5 is 5. 0 less than 5, that checks. Check the second one. The y, which is 0, is supposed to be greater than or equal to -1/2 times 0 minus 1. Well, -1/2 times 0 minus 1 is -1. 0 greater than or equal to -1, that checks out. So I know that this is the correct solution region. So when your two lines intersect on your graph, you'll notice that there are 4 regions. One of those regions is going to be the double shading. That's the solution. One region didn't get shaded at all. If I were to plug a point from this region in, both inequalities would be false because there's no shading here. If I substitute a point in from the yellow region down here, the first one would be true, but the second one would be false. That's why this is not a solution. It's only a solution to the first one. Up here, the teal color would be the first one is false, but the second one is true. This is what we're looking for. This is the region where they are both true. Okay, so that solution region is both true. That's what we're looking for. Okay, so we're looking for the region where both inequalities are true. And that's basically how we do it. So as far as learning what to do, we are done, but we're going to do some examples here. So our first one, x plus y is greater than 2. So if x plus y is greater than 2, I can't graph this, or at least not very easily, with the x over there. So I'm going to subtract x from both sides, and that's going to give me y is greater than negative x plus 2. So if I subtract x from both sides, I get y is greater than negative x plus 2. Now I can graph it. Y-intercept is 2. Slope is negative 1. So you do have to remember slope and y-intercept graphing from chapter 2. There's no equal, so we're going to do dotted here. And this says y is greater than. That means I'm going to shade above. So I'm going to come down here and graph. Y-intercept is 2. Slope is negative 1. That's down 1 over 1. So it's this perfect diagonal line heading downward. Yep, so there's where my line's going to go, and I'm doing it dotted. And when you do this on Delta Math, it works just like it did yesterday. It gives you the option to make your line solid or dotted. Our shading is above. Above, oops, is that way. So that's where I'm going to shade. So there's my yellow. So I'm going to use yellow for the first graph, and then I'll use that teal color for the second one. So there's my shading for the first one. Okay. My second one right here also needs to be rewritten. Here, though, I'm going to have to add 4x to both sides. So if I do that, I get 2y is less than, oops, I wrote y here instead of x. I'm adding 4x. There we go. So y is equal to, or not equal to, but less than 4x and a positive 8. Okay? So that's what happens when I add 4x to both sides. And now I divide by 2. If you divide by a positive, you do not need to flip your sign. So here is my new equation. So y is less than 2x plus 4. Okay, if I take a look at my symbol right here, there is no equal to, so I'm going to do dotted again, but it says y is less than, so I'm going to do dotted, but this time I'm going to shade below. So let's put that one on my graph. So 1, 2, 3, 4. Slope is up 2 over 1. Okay. So there's where my line's going to go right there, and it's going to be dotted. So there's my dotted line. I'm going to shade below. So what does below mean? It means go down. So I'm going to shade this region down here. So in teal, I'm going to shade everything below that one. And it's not as easy to see on the camera as it is for me to see, but this region right here is a different color than those two. That's yellow, that's teal, and this region is definitely more green when I look at it. You might not notice that, but it is. So this is my overlapping region right in here. So that's my solution right here. My solution is this region. I'll just kind of indicate it. If you're doing it with pencil, like on paper, just shade one region lightly, the other region lightly, and then you can darken the overlap. The important thing is someone looks at your graph and they should be able to see where the overlap is. They should be able to see where your solution points are. Okay, if I want to check that I did the shading correctly, I'm going to pick a point in this overlapping region. Let's see, 1, 2, 3, 4, 5. Let's pick 5, 0. Okay, so 5, 0 is right there. It's in my overlapping shaded region. So let's figure out what happens with 5, 0. I'm just going to check it. So 5, 0. 5 plus 0, because x plus y. So right here, I would get 5 plus 0 is greater than 2. Well, 5 plus 0 is 5. Yep, that's greater than 2. Check. The other one, negative 4 times x. X is 5. So negative 4 times 5 plus 2 times 0 is 0. That's supposed to be less than 8. Well, negative 4 times 5 is negative 20 plus 0, negative 20. Yep, that's less than 8. So check, check. I know that my region is correct. Okay. Tonight on Delta Math, what they are going to ask you to do is graph it, 2 of them on the same grid, and you will shade them appropriately, just like you did last night. And you should be able to see where the shading overlaps. And then they're going to ask you to input on the bottom, pick any point in your shaded region and type it in. So they're just asking you to confirm, give me an example of a point that is in the solution region. So like, for example, 5, 0 would have been fine. Okay. 6, 1 would have been fine. Any point in this region is a solution. Okay, problem number 2. Okay, my first inequality here, I need to move the 3x to the other side. So I'm going to subtract 3x from here, subtract 3x from there. That gives me negative y greater than or equal to negative 3x plus 2. Divide. Can't have a negative in front because that's really a negative 1. So I need to divide by negative 1. And when I divide by a negative, my inequality sign flips. And everything else changes sign. So I now have the slope is 3, the y-intercept is negative 2. I see an equal to, so this is going to be solid. And I see a less than. So less than means I'm going to shade below. So, go to my graph. Negative 2. Slope is 3. And 1, 2, 3, 1, 2, 3, 1, 2, 3. So solid. Okay, so there's my solid line on the graph with a y-intercept of negative 2 and a slope of 3. I'm going to shade below. Below is down here. If you're ever not sure, just visually look at the line, put your pencil on the line, and draw an arrow straight down. That's the below region. I realize it's also kind of on the right side as well, but we always just think of it as above versus below. So there's my line. Oops, and my shading for the first one. Second one, yay, I don't have to rewrite it. Look at that. It's in the correct form. So slope, y-intercept, there is no equal to right here. So that's going to be dotted. And it says y is greater than, so I'm going to shade above. So y-intercept of 5, slope of 3, dotted line, and shaded above. So we're going to do all of that. So 1, 2, 3, 4, 5. And then up 3 over 1, up 3 over 1, down 3 over 1, down 3 over 1. and dotted. Okay, so there's my dotted line, and I'm going to shade above. My line is not as straight as I would like. So this is kind of an interesting special case. What do you guys notice about the two lines that we graphed there? Yeah, they don't cross. They're parallel. Where does the shading overlap? Yeah, does it even overlap at all? Nope. So guess what? There is no solution. The solution is where the shading overlaps. And if the lines are parallel, it is entirely possible that there is no solution. Okay, so in other words, there is no point anywhere on this graph, on this grid, that will make both of those inequalities true at the same time. So that's just a special case. Okay, our last one is also kind of a special case in that we don't have y equals mx plus b. We have a y with no x, and if you remember, we did one of these yesterday. This is horizontal. Okay, so when you have y and a number, it's just a horizontal line. But everything else still works. In other words, I see the equals, so it's going to be solid, and I see y is greater than, so it's going to be shaded above. So we're going to do solid, and we're going to shade above. Okay, so horizontal, you just find -4. 1, 2, 3, 4. And you graph a solid line horizontally straight across. Remember, the slope of a horizontal line is 0 because it's completely flat. Slope is a measure of how steep something is. So when it's flat, its slope is 0. It has no steepness. So there's my first one. Okay, easy peasy. Didn't even have to rewrite it or figure out a slope or anything. Okay. The second one, there's no y. It's just an x. That, whoops, get rid of that. And this one is going to be vertical. When there's just an x and no y, it's vertical. But everything else that we've been doing is still true. Look at that. There's no equal sign. So I'm going to do a dotted line. Okay. Now there is no y, so I can't say it's a y is less than. So let's talk about the shading in a moment. I'm going to draw a vertical line though at 8. So 1, 2, 3, 4, 5, 6, 7, 8. Vertical. It's going to cross the x-axis right there. And it's dotted. Okay, so there is a vertical line at x equals 8. Now, look at what it says. We want to know where the x's are less than 8. So think about that. There's my vertical line. I can't shade above or below it because it's vertical. By the way, remember that means the slope is undefined, but there is no above a vertical line because it goes forever. There is a left and a right. So left or right, where are the values of x that are less than 8? Think about your x-axis here. So there's 8. If I want to be less than 8, do I go to the left or do I go to the right? So where are my less than 8s? Yep, to the left. Good. So we go to the left. So when it's just an x and there's no y, your line is horizontal and your shading is either left or right, depending on less than or greater than. Less than is always to the left, greater than is to the right. Think of it as, the way we do a number line. So there's my shading. So the shading was to the left. And if you take a look, oh, there is an overlap. This whole green looking square is my solution region. So just make sure that you are clear about where that solution region is. It's all of this stuff right here. Kind of makes a little rectangle shape. Goes forever, so it's not truly a rectangle, but that is my solution region. Checkpoint, hey, 0, 0, right there. Let's try 0, 0. That means if I put a 0 in for x and a 0 in for y, for both of my inequalities, they should be true. So let's see. 0, 0. First inequality, put a 0 in for y. 0 greater than or equal to 4. Negative 4. I'm like, wait a minute, that's not true. Forgot the negative though. 0 greater than or equal to negative 4. That is true. So when I put a 0, there's no x. I just put a 0 for y. It's true. Here, there's no y, but there's an x. Put a 0 in for x. So my second one tells me that 0 should be less than 8, and it is. So I know that that region, the green region, is my solution. Okay, so that's basically how we do a system of linear inequalities. It's the same as doing one, except you do two on the same graph, and the solution is where the overlapping shaded region is. So there'll be two shaded regions where the shading overlaps is the solution. It is possible, doesn't happen that often, but it is possible that lines could be parallel and the shading, is on the opposite side. So it is possible to have no solution. So all you're looking for is where shaded regions overlap. So depending on how you're doing it, if you're doing it like on Cami, you can use the highlighting color. So if you did the yellow and the teal, you'd be looking for the green region, because that's what happens when you combine the yellow and the teal. If you're doing it on Delta Math, you will do the first one. It'll give you your solution, and then you graph the second one. It'll give you the solution, choose the correct shading, and you should be able to see the overlap. And then it will ask you to type in the coordinates like that of any point in the solution region. So it's just asking you to confirm that you understand where the solution region is. So that's all it will ask you on Delta Math. Draw the graphs, pick any point you want that's in that region. Okay, and obviously it has to be in the correct region for you to get the nice little red check mark. So that is it, which means we have 35 minutes. So group A can work on the Delta Math for the systems of inequalities. And there's also some review problems on tonight's Delta Math. And there's also Delta Math from the other days. If you haven't done any of the Delta Maths, you can work on those as well. And Thanksgiving break, catch up on what you need to catch up on. And hopefully you will be all ready to go for our ESA when we get back from Thanksgiving. Group B, you're welcome to stay online while you're working on Delta Math. You're also welcome to log off if you feel comfortable with all of this. Group B, I will see you in class tomorrow for our review Delta Math Day. And that will be it before Thanksgiving. Okay, so I'm going to stop the recording because I don't think we need to record anymore.